Okay, through the last two proofs in A and B, we now have two conditions that would force a quadrilateral to be a parallelogram. If it has a diagonal that creates two congruent triangles, it must be a parallelogram. And if the opposite angles are congruent, if both pairs of opposite angles are congruent, then it must be a parallelogram. In condition C, it says, what if you have a quadrilateral that has one pair of opposite sides parallel and the other pair of sides of the opposite sides that are congruent? So once again, it's a four-sided figure. It has one pair of opposite sides parallel, and the other side the other opposite sides have to be congruent. Then is it a parallelogram? Well, not all these statements that they give us are true, and sometimes when they're not true, we're supposed to come up with a counterexample, and this is one of those that has a counterexample to it. And what I'm going to do is I'm going to show you some ways or some examples of that. On all of these, you've been able to see there's a hyperlink on here. If you were able to hit that hyperlink, you could go right to it. If not, you could always copy and paste this into HTML or into an address bar, and I think you could get to it. But what you would see is basically this object that I have here, and that is a trapezoid. Now here's a trapezoid that has the criteria of what our problem says. We have one pair of sides that are parallel, as you see by the diagram with our arrows marked. So this side is parallel to this side over here. And then the other thing is that we know that the opposite sides, the other two pair of opposite sides, have to be congruent. So this is a case where you have a four-sided figure that has one pair of opposite sides that are parallel and another pair of sides that are congruent, but it is not a parallelogram. So what we do is we just give a counterexample in these cases. And as I move this around, you can see that that is a very special case of a trapezoid as well. All of these that I'm showing you are trapezoids, but not all of them fit the requirements of this problem. A trapezoid, by its definition, has to have exactly one pair of parallel sides. So these two sides that are parallel are marked by the arrows, but that's not always the case where we end up having the other opposite sides the same length. So now I'm having you look at these two numbers. This is not the scenario that we were given. We were given that those two numbers had to be the same, and if they were the same, then does it have to be a parallelogram? And I don't know if I'm going to be able to force them to be back to that nice correspondence that we had before, but I can work them back closer and closer. There it is. 3.92, 3.92. Bottom line is what we were able to do in this problem is we were able to come up with a counterexample. So this is not a sufficient condition to prove that it's a parallelogram. So just to say that we have one pair of opposite sides that are parallel and the other pair of opposite sides is congruent is false. Our counterexample is simply what we want to put in there is an isosceles trapezoid. So our counterexample is something that we provide that disproves the statement that they're asking us to verify. So a counterexample is an isosceles trapezoid. And just kind of reinforcing, we have one pair of sides that are parallel, another pair of sides that are congruent or equal in length. So as long as I can make that look somewhat or relatively accurate, there's our counterexample.